Um, excellent. Okay, and Laura's in now. Thank you, Laura. And looks like Norris is in. Hello, Norris. For any of you that might not know me, my name is Andy Albee. I am a teacher, mainly of mathematics, but we all teach everything. We're all used to it. I teach right here at this building that's behind me, virtually, the Crystal Learning Center. I'm a teacher at the Adult Academic Program. We're housed at the Crystal Learning Center. And have been involved in adult-based education for 21 years now. So, God, it's been a long time. Actually, you know what? Let's go ahead and just get some introductions from everybody else. I know Carl and Justine could kind of give their introductions.
Hi, everybody. I'm Justine. I work at the correctional facility in Faribault. Normally, I'm licensed in social studies, but I've been teaching math for 3 years now, and I really like it, which is a shocker to everybody really well. I think that's just a testament to all the training that is available to adult educators in the state of Minnesota, though. And so I'm just really thrilled to be part of that team and share, I don't know, knowledge or anything like that, or insecurity. Got a lot of those with my teaching too, but if you lay it all out on a table, it works out pretty well.
Okay, Carl, you want to introduce yourself?
Yeah, my name is Carl Blakely. I am a volunteer GED instructor through Literacy Minnesota. And I teach and taught everything that they have to offer, ESL, the computer courses, and the GED courses. And I've been doing that for about 10 years, I think.
Ooh. So you've been around for a while.
Yeah.
So everybody, I'm the host of this, but I want you to recognize that this is a discussion. This is a reflection on what happened this morning. So it's not going to be me presenting things. It's us to talk back and forth, kind of what we noticed and what we recognized from this morning. And so the first one here talks about what surprised you. Okay, so for any of you that have done Jamboards before, you can go to the left-hand side and click this sticky note, the fourth thing down, put a sticky note in and just put in what surprised you this morning. And if you wish to introduce yourself, you are welcome to. You can turn your camera on or you can leave your camera off. Both are absolutely fine. If you would prefer to put anything into the chat box, you can just put stuff in the chat box instead of unmuting as well. So any surprises?
You want to share the link for the Jamboard again?
Oh, I'm sorry. I thought I had done that. My fault. I
somehow lost it. So
okay, so there's the Jamboard link. And you can join in on the Jamboard, or you can just follow along on my screen. If you want to chat things into the chat box, that's fine. Okay, this is really kind of more the second session, but I chatted in about, every fraction is a ratio, but not every ratio is a fraction. And that it kind of surprised me that took Liz back a little bit, but it's, you jump in and you get hit with something, you got to process it. So pleasant surprise, another way to use double number lines. Excellent. Okay. How students use various ways to solve problems. Okay. Excellent. To whoever's taking those off the chat, put them into the sticky notes. I have on you're doing perfect. Thank you very much.
Yeah.
I put on here because in the first session we brought this up, and I thought it's a nice one to bring in with the discussions that we had this morning. And that is a concept of what we call the levels of knowing. We did a lot of training on that when we first started into the CCRS. And I know Abby Rosa has done a lot of training on this, and it's excellent. but I listed the kind of 6 levels. The intrinsic, that can also be known as innate. Right, the intrinsic or innate level of knowing. That's just, you know it because you know it, right? No one has to teach you this. If you know that this many is less than this many, whether you know the numbers 2 or 3 or dose or trace or whatever, right? We know that that's true. This many is less than this many. I don't have to teach a child that. They'll know it automatically. Concrete is stuff that we can hold on to. So if we're thinking through the idea of, I give one kid 2 cookies and I give another kid 3 cookies, the kid with 2 cookies is all of a sudden going to be upset, even though they got 2 cookies, but they know that they got less because they can physically hold them and see them. Pictorial is to go through and draw pictures to get that concrete representation, but you don't actually have to physically have the things. 4 is abstract. That's where we get the symbols, right? The symbol 5 + 3 = 8. That's an abstract thing. There isn't anything about the number 5 that represents 5. We just all agree that it does. The problem is a lot of our books start there, right? A lot of our books start with the abstract and they don't go back to the pictorial or concrete. So I think the double number line this morning was great on showing us some pictorial views to help understand stuff. Application is just doing something in the real world, right? Can you use this in the real world? And communication is, can you help other people to understand it? Right? Can you discuss it in a way that helps other people? If you do that, then you really truly know it. So who put in the green note? How easy it is to gloss over conceptual understanding.
That was me, Andy.
Okay. Hi.
Hi. So I work in corrections too. I teach at Lyle Lakes now, and I'm like you, been in the field for 21 years.
Yep.
Yeah, I just find that, at least for my students, a lot of them like to just kind of skip over the conceptual and the concrete examples, and they want to go straight into the abstract.
Yep.
And that some students will feel that I'm holding them back if I don't just give them what they need to pass the GED test.
Right. Just tell me how to do it.
Yep.
Right. Just tell me. And it's like, well, if I get you to really understand the concept, then you'll be able to do it on your own. But yeah, that can be a struggle. I agree with that. And there is a lot of pressure. I just want to be done. I don't care about knowing this stuff. I just want to be done. Okay, pleasantly surprised by another way to use them. Okay, I think we hit everything. Anything else anybody wants to comment on this about surprises? Okay, the next one was a little bit trickier in the first group. What confused you? Was there anything that we did this morning that brought up some confusion? And if not, that's okay. This was a comment from the first session. It just made sense, right? They weren't confused about it. They just made sense. Okay.
Hey, Andy, I had one.
Yes.
I was a little bit confused, and I don't know, maybe I missed something when she was talking about it, but when she had
Fractional division.
when she had started looking at just adding fractions, where she was talking about the fence or the fence or the fencing.
Fence painting. Yep.
Yeah, and she had the 3/10 plus the 4/10, and it to me it seemed like, if I would have put up 3/5 plus 7/8, I would have my students still would have come up with 10 pieces at that point, because we didn't really explore the concept of that denominator and what that denominator actually meant.
Right.
So it's, it was all well and good that we could just add up the number of pieces, and I got that, but to me it seemed, again, we were missing the concept of what that fraction was. But I did like it when she brought up the picture, the pictorial representation. Then that certainly helped. Yep. But prior to that, just having those numbers exposed, I was a little bit confused by that.
And it was nice that she brought up the picture, but she did a lot of things with one of my absolute favorite numbers, which is 10, right? She had 10 fence posts. Then when she did all the percentages, like everything was 10%. And that's nice because 10 is really easy to work with, but we got to be ready to work with stuff that's not so easy to work with. So where you were talking about some different lengths, right? If we have a number line, right? And we can actually kind of do the double number line. Sorry, my mouse bumped there a little bit, so I got a little hiccup in it. What was the fraction that you talked about earlier? You just brought up? You had 2 that you were going to add with different denominators.
Oh, you want mine? I mean, I was just
Whatever.
wondering-
Just
yeah,
make
well-
one up, if nothing else.
right?
Yeah.
Do we want to do 2/3?
2/3
Let's do 3/4.
plus 3/4. Now, a nice thing that we can recognize on here, anytime that we're dealing with fractions, one of the first things I tell my students is go to the easiest possible fraction you know, right? By far the easiest fraction everybody knows is half, right? Everybody knows, well, it's just cut into 2 pieces and I got one of them. So is 2/3 more or less than half?
2/3 is more.
It's going to be more, right? If I imagine this cut into 2 pieces, or I imagine it cut into 3 pieces, actually, I should do that in a different color. Or I imagine this cut into approximately 3 pieces. Well, 2 of these is more than one of those, right? So we've got more than half. What about 3/4? Is that more or less than half?
That's gonna be more.
Yeah, because if I look at quarters, break it into 4 equal chunks, and I do 1, sorry, I went a little bit long on that one, 2, 3 of them, right? 3/4 is more than half. So on the number line, we can kind of start to build that. But if you went through and thought about it like this, as a cup of water, okay, 2/3 full, that's more than half. And oh, I should just use the same colors. I don't know why I'm changing colors there. 3/4 full is definitely more than half, right? What if I tried to pour this blue cup into the yellow cup? I'm going to change that yellow cup to green because that's the color I used earlier. What would happen if I tried to pour those 2 cups together?
It would overflow.
It would overflow. So that's one for the students to recognize, hey, wait a minute, this is more than 1 full cup. Yeah, you would make a mess. Yes, mom would be angry with me. Although the whole thing this morning, and I know it's just a habit that we're used to. Liz kept saying, hey, when you got the kids and how do you teach the kids and all the kids, just like, no, we don't teach kids. We're teaching adults. But yes, knowing that we're going to pour those 2 together, it's going to be too much. So what I have to do is make this so that I can have the same size, right? The same size divisions. Anytime with any fractions, no matter what the fractions are, I can always find a equal divisions of something by taking the 2 denominators, the number of pieces I have to make a whole, right? We think of that as the chunks to make the whole. So we had 3 chunks to make the hole on the green, 4 chunks to make the hole on the blue. Anytime I need to get common chunks, I can always cut them with each other. So the 3, I would have to cut each of these into 4 chunks. So the 1/3 gets cut 3 times to make 4 pieces. The 2/3 gets cut 3 times to make 4 pieces. And that last third out here on the end gets cut 4 times to make, 3 times to make 4 pieces. And we'd have a total of 12 pieces now to go all the way across, right? So we just take the chunks that we already have, those thirds, and we cut each one of them into 4 chunks. And we'd end up with 8 of those 12 chunks, 4 for the first one, 4 for the second one. And we usually teach that by saying, multiply the numerator times 4 and multiply the denominator times 4, because we're really truly multiplying by 1, right? 4 divided by 4 is 1. And if I multiply something by 1, it doesn't change. Down here in the fourths, if I cut each one into 3 chunks, so I cut them 2 times to make 3 chunks each. That also ends up with 12ths. But now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. And the important part, so this is the pictorial, this is the abstract, right? Using the number systems. But 3 times 3 gives me 9. And it's just that I cut them up. That's all it is. I just cut them up into pieces. And then one of the biggest things I stress in my class, it's the very first thing I teach to all of my students. And we come back and talk about it with algebra. We talk about it with geometry. We talk about it with fractions. We talk about it in everything. You can only add or subtract the same stuff to the same stuff and get the same stuff. These are size 12 chunks, 12ths. Takes 12 of them to make a whole. These are size 12 chunks, 12ths. Takes 12 of them to make a whole. I can only add 12ths to 12ths and get 12ths, right? They can't become anything different. They can only add the same stuff. The same way if we add dimes to dimes, I can only get dimes. I can't get quarters or nickels or pennies or dollar bills or anything else. If I had dimes to dimes, I get dimes. If I had 12s to 12s, I get 12s. Sorry, something just popped up here. What's going on? Sorry. Okay. But anyway, if I take 8 of these and then I put 9 more with them, well, 4 of them would fill up my 12 12ths, and I'd have 5 more, which I didn't leave myself enough space for here. But I could say that I have 17 12ths, or the 8 and 4 gives us 12 12ths, and 5 more 12ths that don't fit into that. And the 12 12ths is the same as 1. Oh, sorry, I did 5/5 there. Okay, Kale, does that help looking at it that way pictorially?
Yeah, it does.
Okay. The other thing, we did it here on the number lines, and that's how she did it. Okay. If you also thought about it in terms of an area model, oh, it's not going to let me put a new one in. Okay, sorry, it's already pre-built, but I was gonna put another slide in. But you could think of something that's cut 3 ways vertically to make 4 pieces and cut 2 ways horizontally to make 3 pieces. And that would give you 12 total pieces. Sometimes that helps the students to see it too. I hope I didn't confuse anybody more. I really personally, I really like the cup or pitcher model because it's a really good pictorial to something that the students already know, right? They know if I pour this one into that one, it's going to overfill. That's an important thing to kind of understand how that works. And you see it a little bit easier when you think of pouring water from one to the other rather than having just a number line. Number lines are good. I personally like this one better. Sorry, I took a lot there, but Kale asked me a question. You should, be careful asking me questions. I love questions. Anything else that we want to talk about on here? Okay, let's make sure we get through because we got to get done by, was it 2:45 or 3 o'clock? No, 3 o'clock when we're done. Okay, we still got 25 minutes. Anything that you noticed in the training this morning that you can use in your classroom, you can take right now and use it. Okay. I just put one in there. Use what you have. Right. She talked about using grid paper. Grid paper is fantastic. Absolutely. Go ahead and use it. Take just regular lined notebook paper and turn it sideways. Draw your lines on that. That's really easy to use because you can see the lines, and the lines are all, by definition, equal in length. Right. So that makes a really nice one to use. I talked about using the floor tiles. Right, just have the students get up out of their chairs and walk around the room and think about, tiles on the floor and what fraction of the floor is taken up by a desk or what fraction of the floor is taken up by the smart board. Those types of things. Absolutely. Double lines. Excellent. Those, the double tables too. Good. Yes. Student whiteboards. Do you want to expand on that? Who wrote the use student whiteboards?
I did. I had the little small whiteboards that they use.
Okay.
So that you guys put answer and erase things because then they're not using paper all the time. I
Yeah.
have so many manipulatives, but they don't want to use them in front of everybody else. So I said they can just draw on there with different colored markers, the expo markers, and then erase when they're done.
Okay. That's excellent. Yeah. A nice thing that you could do with that on the whiteboards, if you have some tape, like some masking tape that you could put across it, as long as it doesn't pull the whiteboard material off. But if you did a masking tape and then drew the number line with the divisions on it, then it's really easy for them to see it because it's right on their whiteboard. I've also had students where I've taken the grid paper, like what Liz was talking about this morning, and put the grid paper inside of the plastic sleeves that we used to use to put things in 3-ring binders. If you put the grid inside the plastic sleeve, then you can write on it with a dry erase marker. Yeah, Laura, you do that too. That's excellent. Just means we can use lots of stuff without them destroying it. I know for us right now, we have tons of paper, but we're just going to use up the paper. Okay. The double lines and double tables absolutely is the connection of thinking about using it with fractions, but you turn right around and use it with ratios. You turn right around and use it with linear equations. You turn right around and use it with quadratic equations, right? Any of those things we can start to build concepts on, knowing that you have a possibility of two numbers that are being related to each other somehow. And so then you can pull it into science and use it for independent and dependent variables. The other thing with turning notebook paper sideways, I do that when we teach addition and subtraction of whole numbers, because you can put one number in each column and see that only add ones to ones and get ones, only add tens to tens and get tens. It's just, it's a phenomenal tool that I don't think enough people use. Anything else you want to put into here? What can you use in your classroom? Does anybody have anything they think they might be able to use, but they're unclear on how they would use it? Okay. One of the other things that I've done is I've physically hung a rope in my room from one side of the room to the other side of the room. So it's a horizontal rope, and then use laundry clips, laundry. I don't even know. I don't know why I'm blanking on the name. Laundry pins to do that, because then they can hang things right on the line. Clothespins, yes, clothespins. I was stuck on laundry. Okay. What are you already using in your classroom? Okay, we talk about what could you use. What are you already using? Number lines is huge for me. I use number lines all the time. Absolutely. Anything handy, use what you got. Okay, candy. How are you using candy? How could you use candy to talk about fractions?
M&Ms to teach anything, or Skittles, or any of that stuff, to use anything for color coordinate, graphing. We use it for so many things.
Absolutely.
And you can eat it afterwards.
There was a story about a professor doing a statistical class, and the test had a bag of M&Ms on it, and you were supposed to, count the M&Ms and build a bar graph out of it, and then talk about the ratios of red to brown and stuff like that. One of the students said, "Oh my gosh, there's M&Ms on the top of this," and ripped open the M&Ms and shoved them into their mouth because, hey, I got candy, right? And then read the instructions that they were supposed to do something with it, and so spit all the M&Ms out because they're supposed to count the colors. But by that time, all the colors had worn off, and so they made up the numbers. And the professor came back and said, "How did you get red M&Ms? Red M&Ms don't exist." And at that time they didn't, because red BNC number 5 didn't exist. So it's an interesting one. Like, you got to be careful. Tell them don't eat the candy yet. Okay. I agree, Kale. I'm gonna put that one into a chat here. Okay. Use number lines to represent multiple numerous concepts, right? Good. Yeah, excellent. Okay. Let's go ahead and move on to slide 5, unless somebody else has something they want to add to that. I've been talking a lot. I want to back out a little bit. Let's look at slide 5. What was the experience like in the breakout room? I had a couple of breakout sessions this morning. What was it like? Good. Collaborating and brainstorming with different instructors. That's excellent. We're always better together, right? Love working with other people. Okay. So who is confused on that? You weren't sure how to use a Jamboard. Have you used a Jamboard before? If you don't want to answer, that's okay.
No, that was me.
Okay.
I had never used Jamboards before. Just seems like just being in corrections, a lot of the technology we're still kind of behind the times.
Yep. Yep. And that's one of the tricky things whenever we do stuff like this, because we kind of just think, well, everybody's used a Jamboard, right? Everybody knows how to use this. And I took a class this summer, and one of the big things they brought up was teach one thing at a time, right? Don't try to teach how to use Jamboard and try to teach a geometric concept or a algebra concept or something at the same time. You got to do something in Jamboard that's completely not educationally related, just so they get used to how the system works, then go in and use it. But I can understand that confusing, because it's not always super intuitive. Okay. What was intriguing? Who wrote intriguing? I really enjoyed them, but it was short. Okay, we'll go ahead and move off of that one then. Anything else anybody wants to add about the breakout rooms? Okay, I'll add one in there. It was stressful. The breakout rooms were really stressful this morning because they were so rushed. We were trying to do stuff so fast to get back to the main room. Be aware that if you're ever teaching your students, well, not if you're ever teaching your students, when you are teaching your students, give them time, right? We only have a certain amount of time today. There wasn't going to be any more time for the breakout rooms. But if we're rushed in the breakout rooms and your students start to get flustered, the next thing you teach them is going to be gone. They're not going to remember it because they're so worried about being flustered from the breakout rooms. Okay, and last one. How do you feel? Okay, so everybody can do this. We're not going to call out any names, anything like that. Grab a green note if it's something that you're comfortable with explaining why this works to students. Grab a pink note if you said this is an area where I am uncomfortable explaining the why to students, and then drag and drop them out. Okay, make sure to grab them from the top so that we keep the stuff. We're getting a lot of greens on this one. Sorry, I grabbed somebody else's. Okay, that division, that's a tricky one. Okay, so it looks like the level B stuff dealing with unit fractions and basic equivalence, and up into C talking about comparing fractions. And again, for my students, the absolute very first thing I do is we talk about half, and then we relate everything to half, right? Is this more than half? Is it less than half? Is it a lot more than half? Is it a lot less than half? And that can give us some starting points. Even if we don't know exactly what we're doing, we at least know something. So addition, subtraction, multiplication in both what is considered 4th and 5th grade things. Everybody's seeming good on. Everybody gave us greens. The division, we got a couple of reds. So on the division of fractions, I think the more that we can think about that levels of knowing and say, don't try to just jump in and do the abstract. Do the, if I've divided by these, I got to take the other two, flip them and multiply, right? I got to reciprocate and multiply. Don't teach that. I don't teach that. It's one that as soon as you talk to students, what are you going to do if you divide fractions? Well, you flip and multiply. Why? Because my teacher told me, right? That's it. They don't know why. They just got it forced into them when they were in elementary school. When we bring up the pictorial or actual concrete connections of them, if you have some physical manipulatives in your room that you can physically hand them, that can be really helpful for them to start to see that connection. So does anybody, do you want to talk a little bit about that division? We got a little bit of time.
Yeah, Andy. One of the things I try to do when I actually show an example of as far as dividing fractions, I'll actually start off with just doing a simple problem as 4 divided by 2. And I've already shown how you can write that as an improper fraction. And a lot of the students, of course, already know that 4 divided by 2 is already 2. And then I talk about a little bit about the flipping of the fractions. And I ask them, well, if we follow this method, knowing that we already know the answer is going to be 2, if we flip that second fraction to its reciprocal, would we get 2? And so we'll actually do that, and then they'll actually see, oh yeah, that does actually work. And then I guess the discussion goes on, does that work for every single case or situation?
Yeah.
And so that's how I start thinking, getting the students start thinking about dividing by fractions is really another way of looking at it, is multiplying by the reciprocal fraction by using that concrete example.
Right. And the thing that she was talking about is that the division sometimes gets confusing because we can look at it 2 ways. Right. It's really common for us to look at it 2 ways. I drew the picture here of what if we had 4 divided by 2, right? That's 4, putting them into groups of 2. How many groups do I end up with? Right. So if I have 4 and I have 2 in each group, I end up with 2 groups. But if we have 4, let me just do these so I have a different color. I have red and pink, and I don't want to do that. Do greens on these. If I had 4 and I need to put them into 2 groups, how many are in each group? Okay, so you can think of how much in each group and how many groups do we have, or how many groups do we have and how much is in each group. So if I have 4 and I need to put them into 2 groups, I have 2 in the group, right? The 2 here we can think of as 2 groups. Okay. But if you took 4 and divided it by half, okay, then that, again, it's the tricky concept that a lot of students struggle with. Imagine cutting each of these in half in whatever way you want to cut them in half, whether it's diagonal or straight up and down or whatever. Right? If I look just for half sizes, not 2 sizes, but half sizes, I'd have one here and another one there, one here and another one there, one here and another one there, one here and another one there. I would have 4 divided by half, putting them in half size groups. Okay, each group has a half in it, not 2, but a half. That would be 8 of those groups. The top and bottom of the first one, the top and bottom of the second one, top, bottom, of the third one, top, bottom of the fourth one. So that's sometimes where it can be helpful to see the picture that we've got that even without, you know, invert and multiply. And same idea. Okay, the same concept. We'll do a different color here. Let's do blue. What if you had 9 20ths divided by 3 halves. Okay. What do we do there? No, well, let me move. I'm sorry, I got things a little too close together there. What is 9/20ths divided by 3 halves? If we look at this like Liz was talking about this morning, that it doesn't have to be a fraction, it can be a rate, it can be a ratio, it can be a comparison of 2 numbers. It doesn't have to be part out of a whole. Up here, I have 9, and I want to put them in groups of 3. If I have 9 items and I put them in groups of 3, how many groups would I have? Let's draw a picture. It's not perfect lines, that's okay. Okay, 1, 2, 3, 4, 5, 6. Sorry, I cut too many. 7, 8, 9, 10, 11. I remember what we talked this morning. Okay. There's that. There's that. There's 9. Right? What if I looked at these in groups of 3? There's a group of 3. There's a group of 3. There's a group of 3. How many groups?
3.
3 groups, right? 9 divided by 3 is 3. We didn't flip over. We didn't multiply. We didn't do anything else. We just divided. 9 divided by 3 is 3. But what if I looked on the bottom? I have 20 items. I need to put them in 2 groups. How many items would be in each group?
10.
10. No invert, no multiply, no nothing else. Just straight divide. Divide the numerators. Divide the denominators. That's it. Right? We don't have to invert and multiply. You can just straight divide. It works fine. When we get weird numbers, sometimes that starts to look really weird, but the process can still work, and we can use that to help us understand why that invert and multiply works. We're out of time. If anybody wants to see that, how to do this with numbers that don't divide easily, because these did, if you want to see that, feel free to contact me. I'll be happy to talk you through it and have you see it. But those ideas of drawing pictures, doing number lines, doing whatever, right? This number lines, when I asked 9 divided by 3, how many groups? No answers. When I drew it, we said, oh, there's 3 groups, right? That was easy to pick up. Your students will realize it's pretty easy too. Okay. Okay, so Marty, Norris, Kale, Laura, y'all have a fantastic weekend this weekend. Go out and enjoy it. Come back energized for Monday morning or whenever your next time with your students is. And if any of you ever want to get in contact with me, absolutely fine to go right ahead and email me. I love to smile and laugh. Thank you. And shoot
That
BB
sounds like a
guns.